Alright, we have one more to go here. Real world problem. It says I can solve real world problems using arc length. So even before I go anything, arc length is this. So arc length, alright, in degrees anyway, in degrees, right, is the arc length, we use this S to represent arc length, is equal to the number of degrees over 360. That just means the fraction of the length around the circle times circumference. That's the distance around the circle, right? So if it was the circle was 10 and I went 180, I went halfway, my arc length would be half a 10 or 5. So, and remember circumference is 2 pi r. So there we go. Alright. So let us do this in degrees when we read this problem, and let's try to do it in radians as well. Alright, so there we go. So as you saw in the first explain, right, for a central angle, degrees and radians, so our theta, right, our angle theta is equal to, right, the length of the arc divided by the radius, where S is the intercepted arc length, right? You multiply both sides by r, and this gives you the arc length, which we can see right here. And I'm just going to point, right? If I multiply that side by r, it turns into S. If I multiply theta by r, it turns into r theta. So this is the length of an arc length. Alright, so that's how you find the arc length. You take your radius times theta. Alright, I'm sorry, your radians times theta. Your radians times theta. So, the northeastern corner of Maine is due north of the southern tip of South America in Chile. Alright. The difference in latitude between the locations is 103 degrees. Alright. Using both degree measures and radian measures, and a north-south circumference of the Earth is 24,860. Find the distance between the two locations. So, alright. So in degrees, we have not gone all the way around the world, have we? So our arc length is only 103 out of those 360 degrees around the circumference of the world, right? And then we multiply that by the total circumference, which at this location is 24,860. So this is literally saying, hey, to get around the whole world, we go about 25,000 miles, but we've only gone maybe a third of the way, 103 out of 360 degrees, not quite a third, right? So if you multiply those guys together, it'll say that the distance, right, the arc distance in miles is about 712 miles, or 0.72 miles anyway. There it is. So let's talk about radians. Well, our formula for radians is, right, the arc length is equal to the radius times theta. Alright. And remember our circumference is the same, right? So our circumference, which is equal to 2 pi r, is approximately 24,860, which is the same thing we had over here, right? And our radius, right, is about 24,860, right, divided by 2 pi, right? Because that's how many times the radius goes into that. So let's do it, right? To get the distance, right, we take our radius right here, which is 860 divided by 2 pi, and we multiply it by our angle. Our angle, if you convert, right, so to convert that, well, I probably should do the converting, right, is, well, we got about 103. And remember, to convert from degrees to radians, we multiply by pi and divide by 180. Alright, what's really nice is when we do this, the pi's cancel out, don't they? So what I get is, my arc length is, well, I got that 24,860 multiplied by this 103 divided by 2 times 180, 360, and that's equal to about 7112.72 miles. That's a lot, but really there's just two simple formulas. I'd recommend looking at this twice. Alright, notice that whether I do it in radians or degrees, I get the same. So it says, given the measure of two angles of rotation, how can you determine whether they are coterminal without actually drawing the angles? Well, if you remember, right, I subtract them. So if the difference is some multiple of the distance around the circle, right? Is a multiple of the distance in degrees or radians of, so it's either going to be a multiple of 360 degrees or 2 pi degrees. And to say we can go either direction, we can go positive or negative and positive or negative. Alright? What is the conversion factor? Well, let's see, right? So the conversion factor from degrees, we'll write degrees to radians. Remember, degrees don't have pi, so we need times pi, and we got to divide by 180. From radians to degrees, well, radians, we need to get rid of the pi, so we divide by pi and multiply by 180. Kind of easy, right? All right. This says an angle of rotation in standard position intercepts the arc length of 1 on a unit circle. What is the radian measure of the angle? Well, 1 radian. Right, because, right, the radian is a ratio of arc length. Actually, it's just the arc length. I don't even have to say ratio in a unit circle. Alright, so if you have an angle of rotation is an arc length of 1 on a unit circle, right, then that's 1 radian. If it was 2, it'd be 2 radians. If it was 3, it'd be 3 radians. Now, I'm okay with you not getting this whole thing. We will drill and get this. I promise you. We're going to drill the unit circle right up here. And give me a little bit of time, 15 minutes on Monday, and then we will do some work and talk to each other and work hard. We'll get this, no problem. It's not as hard as it appears, face value. And I'll have whiteboards so you can look at notes, and we will get this down. You have a wonderful rest of your weekend.